Greetings, gentlemen, and welcome to the Smart Video Lab. I want to talk a little bit more about factoring. So you can see the title of this page is Factoring, because we got cut off a little bit at the end of class with factoring trinomials specifically, and specifically quadratic trinomials. So let's look at an example, and let's say that our instructions are to factor to solve this equation. X squared plus 4x minus 32 equals 0. We want to solve that equation by factoring. So we need to remember the steps to factoring. So when you're solving by factoring, the first step is to set the quadratic equation in standard form equal to 0. So in this example, that's already been done for us. Because remember, standard form is ax squared plus bx plus c. And we set that equal to 0. So here I've got ax squared, there's my a, it's 1, we don't write it necessarily. There's my b is 4, and there's my c is negative 32. So we're good on that step. Step 2 is to factor. Now, this is the new part for us. We've done a lot with solving equations, but not a lot with factoring. So whenever I have a trinomial like this and the lead coefficient is 1, which it is, I can just use my x factor to factor easily. So a times c, 1 times negative 32, negative 32 goes up top, and b, which is 4, goes down at the bottom. So what are two numbers that add to 4 and multiply to negative 32? Yep, you got it. That is 8 and negative 4. So because the lead coefficient is 1, this factors easily as x plus 8 times x minus 4. And again, we're still solving this equation, so I carry down the equals 0 part. So step 2 is taken care of. We factored. Now step 3 is to apply the zero product property. So remember, zero product property says that if two things multiply to be 0, then either one or the other has to be 0. So either x plus 8 has to equal 0 or x minus 4 has to equal 0 for these two things to multiply to give me 0. So I can set up two equations. X plus 8 equals 0 or x minus 4 equals 0. Which leads us into step 4, which is simply to solve. So now these are easy linear equations like we did at the very, very beginning of the year that you guys are awesome with. So if I subtract 8 from both sides, I get x equals negative 8. And if I add 4 to both sides, I get x equals 4. So x equals negative 8 or x equals 4 are my solutions to this equation that we started with here. Now what does that mean? That means if I substitute negative 8 in for x in this equation, I'll get 0 equals 0. If I substitute 4 into the left side of the equation, I'll get 0, and 0 equals 0, so I'll get a true equation. So let's look at another example where the lead coefficient is not 1, which makes the factoring a little bit more difficult. So let's say our instructions are now factor to solve 3x squared plus 11x minus 8 equals 12. Now again, we haven't done any of the steps yet. So first we have to set the quadratic equation in standard form equal to 0. This one's not already done for us, so we have to subtract 12 from both sides so that we can get 0 on the right side. So 3x squared plus 11x minus 20 equals 0. Now it's in standard form, equal to 0. Now we can factor. So again, I'm going to use the x factor, but this time it's going to look a little bit differently. Again, a times c, so 3 times negative 20 is negative 60 that goes up there, and then 11, which is b, comes in the bottom. So we need two numbers that multiply to negative 60 and add to give me 11. So take a second, see if you can come up with those two. And you are correct. It is 15 and negative 4. So I can just factor this as x plus 15 and x minus 4, right? Just like we did in the last example. No, can't do that. That's bad news. Because if I multiply that out, like we learned a couple days ago, multiplying two binomials, it will not get me back to the original expression. So whenever the lead coefficient of what you started with is not 1, in this case it was 3, we have to add in some extra steps to finish factoring. So what the 15 and the negative 4 tell me is that I can split this middle term up as 3x squared plus 15x minus 4x minus 20 equals 0. And now I can group pairs of terms. So 3x squared plus 15x plus negative 4x minus 20 equals 0. And now within those groups, I can pull out a GCF. So if I look here at this first pair, GCF between 3x squared and 15x is 3x, so that becomes 3x times x plus 5. The second pair of terms, I can factor out negative 4, so that becomes negative 4 times x plus 5. So what I get then is a GCF between those two terms of x plus 5. So I can factor this as x plus 5 times 3x minus 4 equal to 0. So now we factored. You can see it took a little bit longer with this example. So now we can apply the zero product property, which says that I can set each of these expressions equal to 0. So either x plus 5 equals 0 or 3x minus 4 equals 0. And if you want to, it's not a bad idea to check and make sure that we factored correctly in the earlier steps. So if I multiply that out real quick, x plus 5 times 3x minus 4, x times 3x is 3x squared, x times negative 4 is negative 4x, 5 times 3x is plus 15x, 5 times negative 4 is negative 20, so that's 3x squared minus, plus 11x minus 20, which is what we wanted to get back to. So we know we factored right. So that was just a check. Anyway, we were applying the zero product property. We did that. Now we got to solve. So in this equation, I get x equals negative 5 when I subtract 5 from both sides. In this one, I'll get x equals 4/3 when I add 4 to both sides and then divide by 3 on both sides to solve that equation. So x equals negative 5 or 4/3. Again, that means if you go back up to here and you substitute negative 5 or 4/3 in for x in this equation, you will get, this time actually you'll get 12, and you'll get 12 equals 12, which is a true equation. Or if you substitute in this step, you'll get 0, and you'll get 0 equals 0, which is a true equation. So hopefully this helps. On Tuesday, Samuel is going to show us another method for factoring trinomials of this type. But this should be able to get you through the homework. Hit me back on Edmodo if you have any questions. Thank you, guys.